All right, today we have reducing dish problem. Dishes, reducing dishes. Yep. And a chief has collected data on the satisfaction level of his n dishes. Chief can cook any dish 1 unit of time. Like time coefficient of dish is defined as the time to cook it, the dish, including previous dishes, multiplied by its satisfaction level. So time by satisfaction returns the maximums of like time coefficients that the chief can obtain after preparing some amount of dishes. Dishes can be prepared in any order, and chief can discard some dishes to get the maximum value. So we have satisfaction and output 14. After removing the second and last dish, the maximum total like coefficient will be equal to. Okay, so we removed -8 obviously and -9 obviously, and but we left -1 because -1 multiplied by 1, and we got at the end we got 5 by 3. If we remove -1, it will be 0 by 1, and 5 by 2 will be 10, but we have 14 here. All right, so we have to so basically we have, as we go through, I think the smart idea will be sort. So if we just sort satisfaction, or we can assign set to sorted satisfaction. And then for E in we can calculate range of array satisfaction array. So for example, L equal len of set, right? Then we can iterate through satisfaction level, like for E in range L, right? And in this we can decide should we prepare or skip. How we can decide it? And we have like our total result, which is 0, and we return the result at the end. However, this is so let's do it as satisfaction in not L but in SAT. And also let's create I variable. So first we go with 1. Then if we prepare, if we decide to prepare a variable, our outcome will be satisfaction multiplied by I, and then I plus then as we go we can So it looked like we have to we have to store variables if we prepare or do not prepare every dish. So do we have to create like one-dimensional matrix DP? What will be so how we can store it? So let's take a first example. I like this example because there is a -1, and if we throw away -1, we will get less examples and we will keep it. So we have to make informed decision if we keep in -1, then we got -1. So it's almost like we have a decision or a spatial tree when we have and we decided uh, cook it, or if we are not cooking it, next one will be -8. And we also, let's mark it, cook it, not. And then we go to -8 and we can also cook it or not. And total here will be here value will be 0. So if you try all combination, it will be uh, exponential complexity. But we need to So what will be brute force for this? Like, let's start with brute force. It's hard for me to come up with dynamic programming. How about brute force? So I can calculate max with sorted. I can calculate max with just right here, right? So result will be we add in s multiplied by I, and then I increase, and we return result. So everything included as it goes. And we have we have 0. This one is correct because everything included. This one incorrect because everything is minus, so there is no point of cooking anything. So, but this is 2. So what should we do about this? We should skip negative. Like, make it as a function which accepts array and calculates and we can call it as satisfaction or like essay. So we can for E in so as we go, we need to make a decision. Do we have to keep this item or delete this item? So we cannot just like iterate through array, right? And decide like, okay, if it's less than 0, then keep it. If it's more than 0, then, or if it's more than 0, how to make a decision on deletion or make or not. So we can go if more than 0, do if less not. But in this case, outcome will be different, will be not good, right? So we can return calculate and essay, can do if as satisfaction more than 0, it's still not gonna make it because for first case it's just 5. Why it's 5? It's 0 multiplied by 1. Yeah, it's 10. So, what will be better way to do this? Let's go into hints. Use dynamic programmable solution by saving previous best time coefficient and its corresponding element. By saving previous best time coefficient and its corresponding element sum. Okay, so if we create like sum, so we create previous. So basically we have two outcomes. First outcome prepare, right? Other outcome skip. But what previous give us? Skip. So is the crescent variable prev equals 0, and here we add in previous. So if we call it yes, we prepare, and no, we are not preparing. So yes will be whatever we have already plus then no. So if we define like result max of between yes So it's like DP array, right? DP0 equals 0. DP first dish equal sat. Yeah, let's call this I in range. Oh, not I. Let's call it J in range L. DP1 equal max. If we, but that's not gonna work. It's -1, right? We have a, but we somehow to keep a previous. We don't have to make a decision right away. We have to make a decision only after calculating next one somehow. Okay, hint 2. If adding the current element to the previous element, best like time coefficient and its corresponding element sum would increase the best like time coefficient, then go ahead and add it. Otherwise, keep in previous best like time coefficient. Okay, if so, previous is equal 0, right? Yeah, that's not gonna work with -1, right? Because -1 is current element -8. So do we like always cook previous first element? No, we should not. Like here. Yeah, like this. So and just result. And the thing is that at this point we will decide not to prepare a first one because it's -1. So how about we did this and we make decision on pre-y? on next thing. Yeah, but here we make a decision. How about we make a decision based on 2? For example, if we have a j started from 2, we already have y, it will be 1 multiplied by let's say 0, and no will be multiply will be just and y e will be 2, and e and no will be just 0, and no y will be 1. And then we start from 0 and we calculate if j, okay, second, j minus 1 Okay, so then we calculate as following. We start from 2. No, it's correct. We start from 2, and if we decide to take first one, right, we multiply s by ye. And e plus 1. Then no, like in this case, so if we decided to take first one, then our second one will be Otherwise, our second will be first. Second will be first multiplied by ye or e plus second multiplied by e minus 1. If we decided not to prepare it, then second will be second multiplied by I minus 1. No, I plus 1 here. And second multiplied by I. And we have to take max. So can I say that result equal max from SA j minus 1 multiplied by I plus SA j multiplied by I plus 1, or SA j. Okay, technically I can do this. So yes equal this guy. No equal second will be SA j multiplied by I if the result will be plus whatever we have I and increase I by 1, else we result and we return result. Okay, so let's give it a try. It's even worse. Okay, why? So we start from 2. Yeah, I think I am out of time at this point. Yep. Yeah, that's it for today. We'll keep working on this. And yeah, unfortunately, no luck in first 50 minutes. Thank you for watching.